My name is McKeown. That's the first question. Electric picnic is alcohol plus sound. And last year I talked about alcohol, so this year it's going to be sound. It's not a very hard equation. Equations get harder. There's mathematical log tables under your chairs if you search. So what is sound? Is it the voices in your head? Yes, it's the voices in your head. It's electrical signals in your brain, which you're now associating that with my moving mouth, and you think that's sound. But is it a real thing? Is it physical? Can I touch it? Can I lick it? Will it make me a sandwich? It won't make you a sandwich. But it is a real physical thing. So when it comes down to it, it's changes in pressure, just localized change in pressure. So usually start with vibration, like you hit a drum, or my vocal cords vibrate. So it's high pressure and low pressure. And if you get high pressure and low pressure, then you get waves. And it depends how those waves are, what the sound. So if the waves are far apart, so low pressure, high pressure, far apart, it's a low sound. It's like woo, like the weather. And if they're close together, it's high frequency sound. So it's weather is high, low pressure, but we can't hear the weather because they're too far apart. They're high and low pressures, and our ears aren't sensitive enough. But if we could, it'd be a low frequency sound, like someone complaining about the weather. How do we receive it? We receive it with our ears. I'm a massive fan of ears. Ears are great. There's the old proverb, if a tree falls in a forest and you have no ears, does it still make a sound? Yeah, who knows? So the best thing about having ears is that we have two of them, and two of them lets us find what direction sound is coming from. So if a sound comes, it hits one ear first, and then a little bit later it hits your other ear, and your brain works out quickly. Someone's playing some dubstep over there, so it's really cool. But we need sound, need something to pass through, so we need air or water, and it doesn't work in a vacuum. It can't hear you can't shout at it. Oh, damn you, work. So you need something, any old substance. The famous one for a vacuum is in space. Space, there's no air, so it's a vacuum. And then there was this film Alien, and it had this tagline, in space, no one can hear you scream, which is scary and slightly incorrect. So really it should be, my ears work perfectly. The problems with you, if you could produce a sound wave, I could hear you. So, still watch the film. It's good, but, be aware that they didn't have it exactly correct. So, fine. So one of the, I said it's important what the sound waves go through. So if things are less dense than air, like helium, the speed of sound is faster. So you get that squeaky voice if you're at a party and you inhale some helium. And you can do the opposite thing. You can get a gas which is heavier than air, like carbon monoxide, and you can inhale that and you get a deep voice before the poisoning kicks in, which will kind of it'll ruin your party. But so carbon monoxide, the deep voice killer. So what's volume? The volume of sound. So volume is just the pressure intensity. As it gets higher, the pressure intensity gets higher. But our kind of understanding of sound is a little bit weird. We need that pressure intensity to increase by 10 times for us to hear a doubling in sound. And this is a log scale. And we measure sound volume in decibels, named after a very famous bell. That's how we measure sound. The strange thing about sound is that it's quite slow compared to other things like light. Light is really fast and it gets places very fast. Sound is slow. Like we've built things like planes which are faster than sound. And it gives some weird effects. The classic one is the thunder and lightning. So thunder and lightning happen at the same time, but you usually see the lightning, and then seconds later you hear the thunder. And then if you measure the time between seeing the lightning and hearing the thunder, you can tell how far away it is, and if you want to stop playing golf. And you see that at concerts, this delay between sound being slow happens at concerts. Sometimes there's a big concert and there's speakers on stage and then speakers in the middle of the audience, so people at the back can hear. But if you're standing close to those speakers, you can hear both sounds. But they're both coming in two different ways. The sound from the stage is coming through sound waves, which is slow, and the speakers in the middle, that's coming through electrical cables, which is really, really fast. So in fact, the sound you hear from the speakers in the middle is getting to you before the sound from the stage, as if from the future. So it's a little bit freaky, right? So what they had to do so your mind doesn't explode is that the sound engineers put an artificial delay in so that all the sound reaches you at one time. So that's pretty much what I got. Enjoy the Science Electric Picnic, and thanks very much.